So in this triangle, we are given 2 angle measures and a side length. And we need to find side S, side A, and angle S. I'm going to start with the angle first. 42 degrees plus angle S equals 90 degrees. That means that angle S equals 48 degrees. So that's one part of our solution. We need 2 more parts. We need side A and we need side S. I'm going to pick one of the angles. I'm going to pick this 42-degree angle. And I'm going to draw an arrow going to the opposite side. So 42 degrees is going to be our reference angle. I draw an arrow going to the opposite side. The other leg is the adjacent side. I might even write OPP for opposite, ADJ for adjacent, and then the hypotenuse. Now, if I want to solve for the adjacent side, I'm going to use the 42-degree angle, the opposite side, because those 2 values are given, and then the adjacent will be my only unknown. So opposite over adjacent is going to be the tangent function. So the tangent of 42 degrees is equal to the side length opposite 42 degrees, which is 13, over the adjacent side of S. I'm going to multiply both sides by S, and then I'm going to divide by the tangent of 42 degrees, knowing that the tangent of 42 degrees is just some decimal value. S is going to equal 13 divided by the tangent of 42 degrees. So I'm going to put that into my calculator, and I might even use parentheses so that my calculator knows that I am wanting the tangent of 42 degrees. So 13 divided by, and then in parentheses, the tangent of 42 degrees. And the tangent of 42 degrees, let's see, I'm going to hit tangent of 42 degrees, and I got 0.9004-ish. I'm going to take that, and I'm going to take 13 divided by that value. And I get approximately 14.438 if I'm going out 3 decimal places. 14.438, and that's what S is equal to, 14.438. So one leg is 13 and the other one is 14.438. Now we're going to solve for the hypotenuse. So I'm going to say I've got the opposite side, the hypotenuse, opposite hypotenuse, that's the sine function. The sine of 42 degrees is equal to 13 over A. That means that A is going to equal 13 divided by the sine of 42 degrees. So this time we're talking about the sine of 42 degrees. So I'm going to put that calculation into my calculator. 13 divided by the sine of 42, and I get approximately 19.428. 19.428. Now, if you didn't get that, let me tell you what the sine of 42 is. The sine of 42 is about 0.6691. So 13 divided by that 0.6691 is going to get us the 19.428. Now here's another example, and I'm going to do this example just a little bit differently. Let me give myself a little bit of room here. I'm going to do this one just a little bit differently. I'm going to highlight first the given information, and then I'm going to highlight the information that I need. And I'm going to label this triangle A, B, C. So I need to find the measure of angle A. Now remember, angle A plus angle B will equal 90 degrees. So angle A plus 67 degrees is equal to 90. So that's going to give us a measure of 23 degrees for angle A. 23 degrees for angle A. Now I need to find the two legs. I'm going to use angle A as my reference angle. I'm going to draw an arrow going to the opposite side. So I could have used either acute angle to use as a reference angle to find my opposite and adjacent. So I've got the opposite, and now my vertical side is going to be the adjacent side, and then 138 is the hypotenuse. So if I want to find the opposite first, I'm going to have opposite over hypotenuse because the hypotenuse is given. So I only want one unknown in my trig equation. So my trig equation is going to be opposite hypotenuse, that's sine. So the sine of 23 degrees, since 23 is the reference angle across from that opposite side. And then I'm going to have side A over 138. Now this works out nicely because 138 times the sine of 23 degrees. I don't have to do division, although with a calculator, division isn't all that bad, right? So I have 138 times the sine of 23 degrees. So you do this along in your calculator too. And I got about 53.921. So 53.921. So side A is 53.921. I'm going out 3 decimal places so that you know if you've got it in your calculator or not. And then I need side B. Here's side B. That's the adjacent side. So let me use a different color here. So side B is going to be the adjacent side. So I'm going to use the adjacent in hypotenuse because I want to use that known value of 138. So adjacent hypotenuse is cosine. So the cosine of 23 degrees is going to equal side B over 138, which is 138 times the cosine of 23 degrees. And that is approximately 127.030. So that's how you would round that. 127.030. And those are our 3 values that we needed to find for that problem. Now here's another problem for you to try. So go ahead and press pause, and when you're ready to come back and check your answer, you can come back and check your answer. You could probably keep this going because you know that I'm going to work this out. So I want to be able to show you the work just in case you don't get it correct. So A is given, that's 27 degrees. Side B is 15. So I'm going to fill in the blanks. If one acute angle is 27, the other acute angle is going to be 53. Is that right? No, that's 80, 63. 63 degrees. So angle B is equal to 63 degrees. We need to find now side length A and side length C. I'm going to use, what would I use here? Opposite over hypotenuse. Let's use 27 degrees. This way, I don't have to divide. Opposite, adjacent, and the adjacent is going to be in the denominator. So I'll have the tangent of 27 degrees is equal to side A over 15. And when I want to solve for the hypotenuse, this is my hypotenuse right here, I'm going to use the adjacent because that's given. Adjacent hypotenuse is cosine, so the cosine of 27 degrees will equal 15 over C. So A is going to equal 15 times the tangent of 27 degrees. And C is going to equal 15 divided by the cosine of 27 degrees. And let's see if I have my answers handy here. Do I? I don't. So let me throw that into the calculator real quick. The 15 times the tangent of 27. And I got about 7.643, and then we have 15 divided by the cosine of 27, and I got about 16.835. So side A is 7.643 and side C is about 16.835. Now I feel pretty good about that, and the reason I feel pretty good about that is because the largest side needs to be the hypotenuse, and the largest side is the hypotenuse. So that sounds about right. It looks about right. It sounds about right. I think it's right. Okay, in the next video, we're going to do these problems where you're not given an angle measure, you're only given side lengths. So that's where we're going to have to start thinking about using another method to find that missing side length.